Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is reinforcement with strip. In ground improvement techniques, we have different kinds of modifications we are going to conduct as per the construction project requirements. In that process, the modifications by inclusions and confinement, this reinforcement with strip is one of the technique which we are used for getting the desired soil properties. Now, we have to understand what is in reinforcement with strip. Reinforcement with strip, it is referred strip reinforcement. It involves embedded strips of high strength materials, those may metals, geosynthetics or composites within the soil to improve its mechanical properties. This technique is a form of mechanically stabilized earth, MSC. So this is the one such type of the technique which is in under the mechanical stabilized earth and widely used in constructing retaining walls, embankments and other load bearing structures. In this is the reinforcement. It is nothing but the strip reinforcement we are using for this high strength materials for getting the desired soil properties. In this particular lecture, we have to, these are the objectives of this lecture: to increase the shear strength of the soil, to improve the load bearing capacity of the soil, to reduce the settlement under loads, to provide stability to slopes and retaining structure. This is the objectives of this reinforcement with strip concept. What are the components of strip reinforcement? Reinforcement with strip is nothing but the strip reinforcement. In this, we are going to understand different types of strips. Those are reinforcing strips, backfill material, facing elements. These are the different components which are going to involve in this strip reinforcement. In these reinforcing strips, we are using the material that is steel, metal, whatever it, that is example as steel, geosynthetics or composite materials. Coming to the dimensions of these reinforcement strips, typically long and narrow with width to thickness ratios that ensures adequate interaction with the soil. As a backfill material component point of view of strip reinforcement, these granular soils are preferred due to their excellent dryness and compaction properties. In compaction, proper compaction of backfill is crucial for the effectiveness of the reinforcement. In facing elements, the purpose of these facing elements to provide finished surface and prevent erosion of the backfill material. In these facing elements, different types are there. Those are precast concrete panels or geosynthetic facings. So these are the components which are involved in this strip reinforcement. Design considerations. What are the design considerations in strip reinforcement is select material and spacing of the strips, length of the strips, what are the backfill properties and facing design. These are the design consideration in the strip reinforcement. In this, the first one is selection of strip material. It is depends upon the durability and also the tensile strength properties. The selection of strip material is depends upon the durability and tensile strength properties. This durability, resistance to corrosion, UV degradation and chemical attack. So that particular material is going to durable under resistance corrosion, UV degradation and chemical attack. And coming to the tensile strength, it must be adequate to carry the design loads. In spacing of strips, vertical spacing, horizontal spacing. So in this vertical spacing dedicated by the height of the structure and the load conditions, and horizontal spacing depend on the width of the structure and the interaction between the strips and soil. Now, how much length of the strips is depends upon the abutment length and anchorage length. In this, abutment length must be sufficient to develop the required pull-out resistance in anchorage length to ensure stability against sliding and overturning. In backfill properties, gradation and compaction are the parameters considered for this strip reinforcement. In this, gradation should be well graded to ensure good compaction and drainage. In compaction, achieve a minimum 95% of the standard Proctor density. In facing design also, two different parameters are there for consideration of this strip reinforcement, that is structural integrity, aesthetic considerations. In this, it must be able to withstand the lateral earth pressures, and also depending on the application, the facing may need to meet the requirements. These are the design considerations which we are going to understand in the strip reinforcement. What is the construction procedure for this strip reinforcement? Once we consider all the design parameters, we are going to design this strip reinforcement. Now, construction procedure. First one is site preparation, placing of strips, backfilling and compaction, installation of facing, and final grading and finishing. In site preparation, clearing and grading. In this clearing and grading, we have to understand as per the design consideration, we know which type of design is going to consider for this strip reinforcement. In that point of view, we have to remove the whatever the unsuitable materials and any vegetation in that we have to clear and ready for the site. And leveling, prepare a level base for the construction. Now, in placement of strips, in this laying strips, alignment, these are the parameters for this placing of strips. Place the reinforcement strips in layers starting from the bottom. In alignment, ensure correct alignment and spacing as per the design specifications. In backfilling and compaction, layer by layer, place and compact backfill in layers, ensuring compaction around the strips. In quality control, regular check compaction to meet specified densities. In installation facing, panel placement, connection are involved in construction procedure of the strip reinforcement. In panel placement, install facing elements in conjunction with reinforcement layers. In the connection, surely connect facing to the reinforcing strips to ensure integrity. In final grading and finishing, top layer, place and compact the final layer of backfill. In surface treatment, apply surface treatments or vegetation as required for the erosion control. In performance monitoring and maintenance, regular inspections, maintenance activities are important to better performance of the strip reinforcement. The performance monitoring and maintenance give the frequency is regular. It gives the better results, and the strip reinforcement is also in order, and we follow. Once we are understanding these inspections regularly and we conduct these inspections regularly, it gives the better results. In these regular inspections, the frequency conduct Inspections at regular intervals to monitor the performance. Any corrections are required, any modifications, any maintenance is required. It gives the indications, and we are going to understand it whenever we are conducting the regular inspections. In these parameters, check for signs of movement, erosion, or distress in the facing and backfilling. All these parameters, whenever we are checking the signing movements, erosion condition, and distress in the facing and backfill. So, once we are conducting the regular intervals of these inspection, the monitoring gives the better performance. In maintenance activities, erosion control, maintain vegetation and other erosion control measures. And repairs, address any signs of distress or damage prominently to prevent further deterioration. These are the gives better efficiency to the strip reinforcement. In advantages, it is cost effective, flexibility, ease of construction, sustainability. So in this cost effective, often more economical than conventional retaining structure, can accommodate differential settlements without significant damage. Such type of flexibility is there in strip reinforcement. Relatively simple construction process that can be adapted to various site conditions. Use local available materials and can incorporate recycled materials. Such type of sustainability is also there in strip reinforcement. Corrosion risk, complex design, maintenance requirement is the little disadvantages side in. These are some of the disadvantages of this strip reinforcement. In this, metal strips may be susceptible to corrosion in aggressive environments. So it depends upon the different kind of environment. Whenever the aggressive environmental is there, we are using steel. In metal strip means that is steels are geosynthetics. They are going to erode. Depends upon the environmental condition of that particular soil region. So that is one of the disadvantage of this strip reinforcement. And also the complex design. It requires careful design to ensure adequate interaction between the strips and the soil. So whenever we are considering all design considerations, even though the interaction should be ensured. Otherwise, it is going to affect so many parameters. In that particular point of view, the complexity of design is there in strip reinforcement. Maintenance requirement. So regular inspections are required. Otherwise, because of the distress or erosion control is less, so it may affect the final result. So the regular inspections and maintenance is very, very necessary to ensure the long-term performance. Otherwise, whatever the final requirements and final result what we expected from this strip reinforcement, we are not getting those results because of the lack of maintenance. So the regular monitoring is required for this strip reinforcement. If we miss the regular inspection, it may affect the soil condition, and also sometimes it may affect that whatever the project we are constructing there, it is also impact is there because of the lack of maintenance. So that's why the maintenance is very, very required, essential for this strip reinforcement. Case studies and applications. Retaining walls. For example, reinforced earth retaining walls for highway abutments, providing stability and reducing lateral earth pressure. So it provides stability as well as the reducing the lateral earth pressures. In bridge abutments, use of strip reinforcement in bridge abutments to enhance the load bearing capacity and reduce settlements. In slope stabilization, stabilization of slopes in hilly areas, preventing landslides and erosion. In overall, reinforcement with strips is a versatile and effective ground improvement technique that significantly enhances the mechanical properties of the soil. By understanding the design principles, construction procedures, and maintenance requires engineers can effectively utilize these techniques in various geotechnical applications to ensure the stability and longevity of the structure. These are the some of the web references for understanding the ground improvement techniques. Thank you. We will see in our next lecture.
Like, share and subscribe. Hit the bell icon for more updates.